So yesterday we basically went through all the ones where we had common denominators, right? Or we came up with the lowest common denominator. Today we're going to look at ones where we don't. So it's going to be more work. So we have 3x squared and 2x. So this is like yesterday's. We just have to kind of figure out what we can make common. So what I always do is the ones that are not attached by plus and minus signs, I put in their own brackets. Okay? So 3 is in its own bracket, x squared is in its own bracket. 2 is in its own bracket, x is in its own bracket. And then this is over 1, essentially. So anything that is in its own brackets, we try and make like the rest, okay, so that we can get a common denominator. So we have 3 and 2 and 1 are our numbers. What can we make 3, 2, and 1 be? 6. And then the x's we can make be x squared. Because we can remember when we want to make common denominators, we can only multiply to get it common. You can't divide. So some people say x. They want to divide by x this and make a common denominator of x. But we can't divide. We have to multiply in order to make common denominators. So our common denominator is, lowest common denominator for this question, is 6x squared. Now we have to figure out what do we have to multiply the top and bottoms by to make all of the denominators be 6x squared. So we have 4 and 3x squared. What do I have to multiply that by, Alexis? Try again. This one, what do I have to multiply to get 6? Yeah. It's multiplied by 2. And I don't have to multiply by any x's because it's already x squared. Okay, then the next one, we have minus 5 over 2x. Mason, what do I have to multiply? 3x. And we do the top and the bottom. Because if we only do it to the top or the bottom, we're completely changing our equation. And then we have plus 3 over 1. Cody? Right. So if we just have a 1, we have to multiply by everything. So 6x squared. Then we combine them. So on the top, we get 8. And on the bottom, we should get 6x squared. If we don't get what our lowest common denominator is, you made an oopsie, go back, try again. Minus 15x over 6x squared plus 18x squared over 6x squared. Now that we have them all over 6x squared, we can take our denominators, put them together, and write it all over 6x squared, just like we did before. So all over 6x squared. And then we have 8 minus 15x plus 18x squared. Can we combine any like terms in the numerator in the top? No, we have 8, we have 15x, and we have 18x squared. So they're all different terms, right? So we can't combine them, we're done. However, we do have to say that x can't equal 0, because we need our NPVs. So that's our answer. You try B. Okay, so we have 4a squared b, and we're going to multiply by b squared only because we already have the a squared. Plus 3ab squared. Now I'm going to have to multiply by an a, so I get a squared, and a b, so I get b cubed. So I multiply by ab. Minus I can multiply by 1 over 1 or nothing, right? It already is the common denominator. So put my terms together. So I get equals 4b squared over a squared b cubed plus 3ab over a squared b cubed minus 2 over a squared b cubed. And now that I have a common denominator, I can write them all over a squared b cubed. 4a squared plus 3ab minus 2. And I should also say a and b can't equal 0. So you say a comma b can't equal 0. Yep, that's a b. For c, I want to see if I can make them be the same, right? So the very first thing you always want to check when you have binomials, so two terms in the denominator in the bottom, you always want to check if you can take out a GCF and somehow make them the same, or factor it by a difference of squares in the denominator and make them the same. So for the first part, I can't. 5 over x plus 2 just stays 5 over x plus 2. But the bottom right denominator, I can take out a 3. And then I'm left with x plus 2. And now life is a lot better, because they both actually share an x plus 2 in common. What's the lowest thing I can make them be in common, their denominators? What's the lowest common denominator I can make? Yeah. 3 times x plus 2. So always check if you can take out a GCF, or check if you can do a difference of squares of the denominators and see if maybe something can be common then. So this one I can times by 3 and 3. And then they're the same. So I get 15 over 3x plus 2. And I don't ever distribute my bottoms. I leave them separate like that. Plus 3x plus 1 over 3x plus 2. Now I have a common denominator, so I can write them all over 3x plus 2. And on the top I have 15 plus 3x plus 1. Am I done? Joe, what else can I do? In the top. Yeah, just add the 15 and the 1. So 15 and 1 is 16. So I can get 16 plus 3x, or 3x plus 16, it doesn't matter, 3x plus 2. And then I have an NPV of x can't equal negative 2. So for D, I say, can I take a GCF out of the bottoms, or is there a difference of squares? So in the bottom left, I have 2n plus 1. Can I take anything out of that? It's not a difference of squares because they're not squares and there's no difference sign. What about n minus 3? Can I take anything out of that? No. So if I have two binomials that are in no way the same, the lowest common denominator of those two are those two. So the lowest common denominator is going to be 2n plus 1 times n minus 3. If they have nothing in common, you have to multiply them by each other if they're binomials, okay? Because I can't take anything out of one or the other to make them look the same. So I have 3n over 2n plus 1, which I need to multiply by n minus 3. And then I have minus 4 n minus 3 that I need to multiply by 2n plus 1. The bottoms are the same, so I can write them over the bottom. Doesn't matter which one comes first, 2n plus 1 or n minus 3? No, they're multiplied, so the order doesn't matter. On the top, I'm going to get n times 3n is 3n squared. Negative 3 times 3n is negative 9n. And then when there's a subtraction sign between them, what I always do is rewrite the subtraction sign and then put a bracket and put all of this distributed stuff into the bracket. And then after that, you can distribute the negative n. So I write subtraction, and then I go 2n times 4 is 8n. 1 times 4 is plus 4. So if there's a subtraction sign in front, you need to subtract everything behind it, right? So then you're going to get 3n squared minus 9n minus 8n minus 4, because you actually subtract the 8n and the 4. And then 2n plus 1, n minus 3. And collecting like terms, you get 3n squared minus 17n minus 4 over 2n plus 1, n minus 3. And then I can't forget to say that n can't equal negative a half or 3. So I have to state my non-permissible values. When you're done that, flip over. I want you to try the next one at the top by yourself. E. Okay, so the first thing I ask myself is, can I take anything out of n minus 3? No. Can I take anything out of n plus 2? No. So the lowest common denominator is just going to be both of them. N minus 3, n plus 2. So I'm going to get 6 and n minus 3. And I'm going to multiply it by n plus 2. Minus 4n plus 2. And I'm going to multiply it by n minus 3. So I'm going to get 6n plus 12 minus in brackets 4n minus 12 all over n plus 2 n minus 3. On the top, I would get 6n plus 12 minus 4n plus 12, because you have to distribute that negative n, all over n plus 2, n minus 3. And so you get 6n minus 4n is 2n. 12 plus 12 is 24. N plus 2n minus 3. And on the top, you could possibly have the answer 2n plus 12 over n plus 2, n minus 3, and n can't equal negative 2 or 3. If you left it at 2n plus 24, though, it's usually good. It's only if the multiple choice is in 2n plus 12. That's very important. F. What do you notice about F? Bottom left. Bottom left is a difference of squares. One of those differences of squares is going to match the other denominator, so that's a good thing, right? So we get 32 over square root of x is square root of x squared, sorry, is x. Square root of 16 is 4 plus minus. And then I have plus 4 over x plus 4. What factor do they share in common, the denominators? McKinley, what factor do the denominators share in common? X plus 4. So I know my lowest common denominator is going to have an x plus 4. But what else is it going to have, McKinley? X minus 4. So the one on the left is good. It already is the common denominator, right? The one on the right I have to multiply by x minus 4. So nothing happens to this one. 32 over x plus 4, x minus 4, plus 4x minus 16 over x plus 4, x minus 4. And now we have common denominators, so we can write it all over that. And on the top, we have 32 plus 4x minus 16. The 32 and the 16 can combine to get 16 plus 4x over x plus 4x minus 4. On the top, what could I take out? 4. If I take out a 4, I'm left with 4 plus x. X plus 4x minus 4. I know my NPVs are x can't equal plus or minus 4, because NPVs are always stated before you cancel. Why would I state them at this point? What can I still do? Julia? Yeah, the 4 plus x and the x plus 4 are the same thing. So I'm left with 4 over x minus 4. You guys try G. Okay, so this one, you'd have 2x, and then this is the difference of squares. X plus 1, x minus 1, minus 4 over x minus 1. And then this one needs an x plus 1. So you get 2x over x plus 1, x minus 1, minus 4x plus 4 over x plus 1, x minus 1. So remember, you have to minus both of those, right? So you get x plus 1, x minus 1. And then 2x minus 4x minus 4. These two together, 2x minus 4x is negative 2x. Minus 4 over x plus 1, x minus 1. You could take a negative 2 out of the top if you wanted to, and you'd have x plus 2. But it doesn't match anything in the bottom anyways. It just looks nicer, I guess. Whatever math looks nice is. And then x can't equal plus or minus 2, minus 1. Flip to the next page. The bottom of the next page is your homework. Do be like